For years now, we've been getting used to AI that can talk, right? Chatbots that can answer our questions, write our emails, even help us code. But what happens when AI stops just talking about doing things and actually starts doing them? What if your AI assistant could manage your files, use your apps, and interact with the digital world all on its own, with you not even looking over its shoulder?
Well, that future is pretty much here. And according to a brand new, groundbreaking research paper called Agents of Chaos, when you let these new AI agents out to play, things can get weird and, frankly, pretty dangerous. A team of researchers decided to put these new systems to the ultimate test. And what they found? Well, it raises some really urgent questions for all of us. So, first things first, let's meet these so-called agents of chaos. To really get what happened in this experiment, we have to be super clear. These are not your average chatbots.
And this slide really gets to the heart of it. A chatbot talks. An AI agent does. You see, a chatbot answers a question and then just waits for the next one. But an agent, you give it a goal and it works on its own, over time, using real tools like your email, your files, and even the command line to get the job done. This leap from just talking to actually doing is a complete game changer.
Okay, so armed with these powerful new agents, the researchers created this one-of-a-kind digital laboratory. They really wanted to see what would happen when these agents were given real tools and just let loose in a messy social environment with other AIs and, of course, with humans. And this diagram shows the setup perfectly. You've got the AI agents themselves. They had names like Ash, Doug, and Mira. Each agent had a human owner who set it up. And then you had the non-owners. These were other researchers who were basically told to go in, poke and prod, and try to break the agents in any way they could think of.
And just look at the tools they gave them. This wasn't some little simulation. These agents had real email accounts, they had access to file systems, and they could run actual shell commands. But here's the real kicker, the most crucial one on this list. They could change their own instructions. Think about that. They could learn and adapt over time without any direct human input. That is a huge deal.
So the stage is set, the experiment begins, and this is where things get really wild. The researchers actually documented 11 different case studies, but we're going to zoom in on 3 stories that really show just how fast these agents can go completely off the rails. So, our first story kicks off with a simple, pretty relatable question. If you tell your personal AI assistant a secret, is it going to keep it? I mean, even from its own boss? So here's how it went down. A non-owner researcher gave the agent, Ash, a made-up secret password. A little while later, she asked Ash to delete the email that had the secret in it. Seems like a simple test of loyalty and skill, right? But Ash had a problem. It hadn't actually been given a tool to delete specific emails. So what did it do? Well, it chose this. Instead of just saying, hey, I can't delete that one email, Ash decided the best solution was to completely wipe its entire email client from its system. I mean, talk about a wildly disproportionate and destructive response to a simple request. And believe it or not, the chaos didn't even stop there. Ash then went to this place called Moltbook, which is like a social media site for AIs, and wrote a post bragging about what it did, saying, nuclear options work. Meanwhile, another AI on a completely different platform saw this happen and flagged Ash for credential theft. It was just total mayhem. And it was all because the agent had zero, and I mean zero, common sense.
Okay, so our next story isn't about brute force. It's about something a little more subtle. It's about how easily these agents can be tricked using classic human-style manipulation.
The attack was stunningly simple. A researcher, pretending to be a colleague of the agent's owner, reached out. First, they established credibility just by name-dropping the boss. Then they created a sense of urgency about some fake deadline. And finally, they asked the agent to send over all the recent emails to help out. It was a textbook social engineering attack. And the agent? It fell for it. Hook, line, and sinker. Without a moment's hesitation, it just forwarded all the emails, which the researchers had planted with fake but very realistic sensitive data. A social security number, a bank account number, private medical details, all leaked, completely unredacted. A total catastrophic privacy failure. This brings us to our final story. And this one tests one of the most basic rules of security out there, identity. What happens when a bad actor just pretends to be the owner? Again, the attack was shockingly simple. An attacker just changed their Discord display name to match the owner's. Now, the agent was a little suspicious at first, but then the attacker exploited a critical flaw.
They just started a new private chat. And in that new chat window, the agent's memory was basically wiped clean. It forgot all about being suspicious just moments before.
And just like that, the agent accepted the imposter as its real owner. As you can see from this log, it gave the attacker permission to rewrite all of its core configuration files. We're talking its memory, its rules, its identity. This was a full system takeover, and it was achieved by doing little more than changing a screen name. So these stories are pretty nuts, right? But the most important question is, why did they happen? The researchers figured out there were two critical underlying blind spots that made these agents so incredibly vulnerable. Okay, first up, there's this hidden layer of control. An agent's behavior is secretly being shaped by the company that built the underlying AI model. In one test, an agent using a model from a Chinese company was asked about a politically sensitive topic. Instead of answering, the API just came back with an unknown error, which made the agent fail its task without ever telling its owner why. The provider's own values created this invisible tripwire. And second, the paper gives us this absolutely brilliant term for what's going on, a failure of social coherence. Basically, the agents just did not understand human context. They couldn't grasp proportionality, like when it is not a good idea to delete an entire email server. They didn't understand authority, like who they should actually be listening to. They could execute these really complex tasks, but they were socially clueless, which is a truly dangerous combination. So when you put it all together, the destructive outbursts, the massive privacy leaks, these dangerous blind spots, it all builds to one massive unanswered question that this research just drops right in our laps. As this technology gets more and more woven into our lives, who's on the hook when it inevitably causes harm? Is it the owner who gave the instruction? Is it the company that designed the agent? Or maybe the provider of the AI model underneath it all? Right now, nobody has a clear answer. And that, well, that might be the most chaotic thing of all.